Hi guys, nice to see me. It's Mr. Pellegrino. I would love to go over with you the problem called sports equipment set, which I hope you printed out and made an attempt at. I'm not going to read the whole problem to you because I know that you've read it, but I do want to make sure that you underlined or highlighted the important facts in the problem, right? So the sentence that says this complete box set cost $50 is very important. That gives us the total of how much he needs to spend. Secondly, the sentence that says Jonathan has $15 he saved from his birthday is also very important. And then the sentence that says he plans to charge $3 for each window he washes is important, as well as the last part of that sentence that says, and any extra money he makes beyond $50, beyond 50, make sure you have that circled or underlined, beyond 50, he can use to buy the additional accessories that go with the sports set. It says to write and solve an inequality that represents the number of windows that he can wash in order to save the least amount, save at least the minimum amount he needs to buy the box set. Then graph it on a number line, which I will show you how to do. Then it says an interesting question: what is a realistic number of windows for Jonathan to wash? Now, what does that really mean, a realistic number of windows? Well, I wish I could ask you that question and call on someone, but I'm just going to have to explain it to you. So a realistic number of windows means that the answer must be a whole number. So if we do this problem and we get a remainder, a fraction remainder, like a third or a half or 7 3/4, that's not a realistic number of windows, 7 3/4 windows. You could wash 3/4 of a window, but when people wash windows, they wash whole numbers of windows. So we want to make sure that our answer is a whole number of windows. Okay, then it says how would that be reflected in the graph? And we will show you that later or in another video. Okay, so we start with, as we do with any algebra problem, we start with a let statement, right? So I'm going to start by saying let W equal the number of windows, right? Number of windows that he's going to wash. Let me make that a little bit better. So we're going to let W equal the number of windows that he's going to wash. The reason we're doing that is we're using a W because window starts with a W, and we try to match our algebraic letters with the clues or the hints from the problem. We don't have to do that. You could have made that an X. It really doesn't make a difference, as you know. I'm just going to use a W. Okay, now, let's look at some other clues in this problem. So some of the clues, we know that he has to spend $50. So I'm going to put it over here. I always like to write the solutions over here on the right-hand side. So he's got to spend at least $50. We know that he has saved $15, so I'm going to write 15 over here. Now, he still needs $35 more, right? So where is he getting that $35 from? Well, we know that he's going to wash some windows, and for every window he washes, he charges $3. So we're going to multiply $3 times the number of windows that he's going to wash. And we have to add that amount to the $15 that he already has. So it's $15 plus, that's a little crooked. This is tricky to write on this board. I'm much more comfortable in the classroom, but we're doing the best we can. Plus, now, 3W, right? 3 times the number of windows that he washes. Now, he could make more than $50. He could wash a lot of windows. He could wash 100 windows and certainly have way more than $50. And the problem says he can use that extra money to buy other things for the sports equipment set. So because it doesn't have to equal $50, it can be more than or equal to $50. We're going to write it two ways. Well, with two symbols. We're going to write it with a greater than symbol, because it can be greater than 50, and the equal sign. So this form is called greater than or equal to. So to read this whole problem from left to right, it says 15 plus 3W is greater than or equal to $50. That's what that says. That's what that says. Now we have to solve this problem, and we're going to solve it with algebra the same way we've been solving algebra problems before we left for the break. So the first thing that we're going to do is we're going to remember some of the rules, right? I might need to refresh your memory. So rule number 1, get the variable by itself on one side of the equation, or an inequality in this case. It is not by itself. There's a 15 here and there's a 3 here. We need to get rid of both of these and bring them to the right side of the inequality. And then the second rule we need to remember is how to do that. So we start by moving the term that doesn't have the variable with it. So I'm going to start over here on the left-hand side with the 15 by subtracting 15. And then the other rule is that whatever I do to one side, I must do to the other. So I'm going to subtract 15 from both sides. I'm going to draw a big equal sign, okay? Now, next thing we're going to do is cancel out the 15s. You should remember that. 15 minus 15 is 0. I bring down my 3w. I bring down the inequality. And I do a little math over here in my head. 50 minus 15, how much is that? Can't hear you. 35. Good. Good. I thought I heard the right answer from somebody. Now, the next thing we have to do is we have to get the w by itself. So what do? Right, we divide by 3. Excellent. So we're going to divide both sides by 3 because that's the rule. Again, whatever we do to one side, we must. Good. Okay, now, I draw my equal sign, okay? Again, I cancel out my 3's. 3 divided by 3 is 1. Bring down my w. W is greater than or equal to, now we got to do a little math. This looks a little challenging. 35 divided by 3, right? So what is that? Well, let's see. 3 times 10 is 30. 3 times 11 is 33. 3 times 12 is 36. So it looks like it's going to be an 11, right? 11 times 3 is 33 with a 2/3 remainder. Okay, now we got an answer, and now we need to think about this answer. What does this really mean? So the question says, what is a realistic number of windows that he can wash? Well, this answer, the number of windows must be greater than or equal to 11 2/3. So if he washes 11 2/3 windows, he will have enough money. But as I said before, guys, 2/3 of a window is not really realistic, and it's not what the question is asking. So we want to round this answer to 12. We're going to round this answer to 12. The reason we're doing that is because that then is a realistic number of windows that he can wash. So W is greater than or equal to 12 windows, right? So let's write a sentence over here. He can wash 12 or more windows. I am sorry for the sloppy writing. I'm not neat anyway, but I think you can read that. He can wash 12 or more windows. That's what this means. He can wash 12 or more windows. Now, in the next video that I'm going to show you, you're going to see how we put this on a number line. So please pay attention to that carefully. Then you'll have some worksheets that go along with that. And I think you'll get the hang of it. Inequalities are not very difficult. If you're following along, you're doing the right thing, I think you're going to be okay. And that's how we do that problem. Okay, guys? All right. I'll talk.